and *6. We don't hear you yet.
Yep.
Okay, so thanks, Rich. We have Rich Signell here from the Woods Hole Coastal and Marine Science Center, and his project that he's presenting is evaluating a new open source standards-based framework for web portal development in the geosciences. So you're
right.
showing on the WebEx. Thanks.
Okay. Can you see my screen?
Yes, we can.
Okay. So really the idea for this project came from a talk that we had on the TechStack Working Group about 1.5 years ago. And we saw a really cool presentation on how the Australian National Map Viewer was developed. And this guy, Kevin Ring, and you can go watch this on YouTube if you want, it's about 15 minutes, gave a great overview of the Australian National Map. And what they did that was pretty cool. Well, they did a bunch of things, actually. But they said, you know, we're going to build a national map viewer, but instead of just building a custom viewer, what if we develop an open source framework for developing applications like the map viewer and build the map viewer on top of that as sort of a, you know, eating your own dog food exercise to see if this framework works. And so they presented this, and, you know, there were a number of cool things, you know, in addition to just being open source and freely available, which means that you can go innovate on top of that and, you know, easily. But it supported, out of the box, it supported Cesium to do 3D work like you're seeing here on the screen. It's super responsive. It's all in the browser, 100% in the browser. It also supports Leaflet for 2D if you don't have an, you know, an advanced, if you don't have a graphics card, you have an old browser. But it works in any modern browser. And the another cool thing was that it supported a lot of the data types that we wanted to hit already. It supported the OGC Web Map Service, Web Map Tile Service, Web Feature Service, all the Esri services, and then a bunch of stuff like OpenStreetMap, GeoJSON, KML, CZML, which is a 3D markup language, the Cesium markup language, and even a CSV file where you have like lat, lon, time, and some value. You can just drag and drop it onto this viewer, and again, it's all in the browser. So we thought that looked pretty cool, but there was one thing that was really missing for our use with modeling output and other web map services where you need to dynamically control the range of the color map. And so this happens all the time with Ocean Model Output. You can't define just a single color map and deliver that as a static product. You need to generate it on the fly and get that web map that, you know, has the range that you specify. So for instance here, you can see in this Barnegat Bay model that was run here at USGS, we're looking at water velocity, but it's all green. So it's not really showing us too much information. And, you know, you might try to set something up that would be pretty good for one day, but you move to another day or a season or a different layer, and you know, you need to be able to change that color range on the fly. So there was no way to do that in the TerriaJS, and there's no way to do that in actually most tools that are around. So there's not too many tools for looking at web map service products from models. And so we thought, well, this would be kind of a neat thing to do. We proposed this CDI project to try adding that capability to this framework. And we proposed doing that with a USGS developer and with the TerriaJS developers in Australia to see how hard it would be for a USGS developer coming from the outside to actually implement this in this framework. We'd learn about the framework itself, take a deeper dive into it, and learn what its capabilities are as well as limitations, how well it works as a community, et cetera. So we did implement this. You're seeing actually this particular layer. There's a UI here that allows you to set the color min and max. And if you set that to some reasonable range, then the user can type in, max 0.5, minimum minus 0.5, and suddenly, a new map gets generated, a web map service map gets generated, and you see, all the structure around the inlets. And if you were interested up here, you could, further refine that range and everything. This also shows that there's built-in, if your data is time-dependent, there's a slider at the bottom, so you can just move through time and see how this evolves with time. And one of the kind of gratifying things was, so we implemented this as a CDI on the CDI project. Just last week, I was listening to a presentation where some guys from Berkeley were presenting what they had done, and I was really kind of surprised when they moved to their visualization tool, and they showed that they were basically using the stuff that we had just implemented to plan an experiment this summer off of Martha's Vineyard. So being already used by others in addition to USGS, which is pretty cool. There's other groups at USGS who are poking around with TerriaJS. Sky, I think, sort of led this effort in developing this protected areas database for the U.S. And this is sort of showing that, you can set up a bunch of layers here. These layers are all coming from different services, but they are all specified in a simple little JSON configuration file. And that looks like this. So here's an example of one of these little configuration files. There's a catalog that you specify, and then within that there's a group. The group has items, and here's the first item. You give it a name. What type is it? WMS in this case, an endpoint. And here's the color scale, min and max. It takes maybe a little bit of time to get familiar with this, but it's pretty simple, right? And so you create one of these little JSON files, and this can either sit actually on the server or it can just live out here on some site like GitHub, like this one is. And if you, then you can just attach that. This is one of the coolest things about this tool, I think, and we could implement this in other software as well. But if you have an endpoint like we have here, and this endpoint is our own instance that we deployed on our academic partner here in Woods Hole and WHOI's infrastructure for testing, you can just put a pound sign and then put that raw link to the JSON file in here, and boom, you've got your own like custom web portal that you've created just from some JSON that you deployed on GitHub. It's pretty remarkable. So here is showing, a particular layer from Hurricane Sandy, and we started off at the maximum height surge for Hurricane Sandy with the right color scale and so on, but the user can then explore from there. The other cool thing that you can do with this is you can configure in JSON a little CSW or a CCAN query. So you can say, hey, give me all the WMS layers from this endpoint, or give me all the WMS layers that match a certain string, or give me all the layers that have web map services match a string and have a bounding box of this, or add a time extent. So you can do really sophisticated queries. In this case, we're narrowing down the number of data sets that we get from this catalog service. So this could be Sciencebase CSW. It could be data.gov CSW. In this case, it's our own that we're running in our group here to manage our own model output. And here we've narrowed it down to see where this web search returns one data set that then we can load up, and that was the one that we were actually just looking at before for Barnegat Bay. So we did all this work out in the open on our own GitHub, which for the project, which actually I forgot to mention is here. Is Terry. If you search on TerriaJS dive, you can find it. And then the issues with Terria, though, we just opened up on the actual TerriaJS GitHub, which is also completely open. And all of our technical discussion took place here. We raised issues, we discussed them, and we put them in a milestone for our project. These all got completed. We have a bunch of other issues for, some future version, more enhancements and stuff. But basically, this worked really well. So, our lessons learned, I think, were that GitHub issues are just a really excellent way to discuss technical. You can have web calls and you can discuss stuff through email, but having it out on GitHub, all out in the open, is really super useful. Sometimes you get participation from folks you didn't even expect would participate. So one of the things that was a challenge was it was a big code base. Unfortunately, we jumped onto it just when they were switching to a new UI that would be more mobile friendly. So the documentation was rather tough. And so Jordan Walker, our USGS developer, he made some progress, but he did need, we needed a lot of help from the Data 61 folks down in Australia to make this happen. When sort of doing the post debrief on this, we realized that it really would have been good to do a face-to-face, introductory sort of hack session, getting together. Unfortunately, them being in Australia didn't sort of made that harder. But maybe we could have, probably would have been worth it just like send Jordan over there or something like that. And then the other thing that limited our ability somewhat, we wanted more modelers to participate and supply their services, but there's no real way right now for us to put like model output on Sciencebase and have these WMS services appear that we need. I know there's plans for threads, NCWMS, that have been around for a while, and I think that's advancing, but we could really use those on Sciencebase to help us deploy these services from models. And we tried to get around, we tried to do a workaround by deploying threads on our machine down in St. Pete for the modelers down there, and we ran into issues with the sysadmin not wanting to deal with Docker, was concerned about it. And anyway, you know, I'm sure that we need to be able to deploy Docker on USGS machines, and I hope we'll get there as well. So, you know, in conclusion, it was very successful, I think. You know, we did what we set out to do. We learned about the capabilities. We learned how to construct custom portals. We learned what was required to do this stuff. The new features that we added are benefiting us right now in our group and across the USGS and in a wider community. And I think this does actually play, although it seems like, wow, yet another mapping framework, but it does really fill an important gap because it's the way that we can access things that need dynamic NCWMS services, so like models and other kinds of data that have a large dynamic range. So thanks.
Rich, thank you very much for your presentation and especially for those lessons learned to be shared with the rest of the CDI community. Okay, so we don't have any other questions and we should move on to the 5th presentation. So if I could get the screen share back.